So as always, we got to do three things with this new kind of function. We will learn how to simplify expressions. We kind of actually did a little bit of that, but with properties of exponents. We will learn how to solve equations. We will need logarithms for that. And we will just now, we're going to learn, we need to learn how to graph it. Okay. So that's what we're going to do here. And the first time you graph a new kind of function, generally you plot some points and you just see what the shape is, give yourself an idea. In these days, because of calculators, maybe you put it in the calculator to see what it looks like. This is example one, and I've just copied it out of the graph just to save ourselves a little calculation here. But they made a table of values, and we're going to use the x values, -3 to +3. Where did those values come from? Remember, when you have a function, you get to pick the x values. Right? That's why we're concerned about domain, because we want to know which x values we can pick. So, if ever there's a question like, where do those numbers come from? They just picked them to use. You don't have to pick those numbers exactly, but we need to pick some numbers to show the shape of the graph. So they pick these. Remember, you will always pick the x values. Okay, what do you do with the x values? You're going to plug them into that equation one at a time. And that's what they've done in the second column. They've plugged in for the x, -3 to 3. And they simplified. Right? All of these points here are these points, -3, 0.125, -2, 0.25, right? And then they're connected with a smooth, continuous line. That's the shape of the graph. Okay, in this case, because the b is greater than 1, it has this shape, which it's increasing as you look from left to right. That's called exponential growth. Right? Because b is greater than 1, this is exponential growth. Okay. Now, look at the values that we've got. I mean, what would happen if I picked bigger values of x to plug in? What do you think would happen to the values of y? Right. They would get bigger, right? What happens when I choose bigger negative numbers to put in? It gets really small, right? Is there any value of x that I could plug in there to make this function equal 0? No. I mean, I can make it get really, really small, but I can never make it equal 0. So this graph, as you look at it right there, it's going to come really close to the x-axis, but it will never touch the x-axis because that's where y equals 0. And there's no way to make this equal 0. Okay? So this brings up a new concept that we haven't seen yet, but it's called an asymptote. So when you have a line on the graph that the graph can never touch, it can get infinitely close, but it will not touch that line, that is called an asymptote. In this case, it's a horizontal asymptote because it's a horizontal line. Right? This is a horizontal asymptote. New word. asymptote. Graph approaches but does not touch. Right, and that line is y equals 0. That's the line. And this is where, we'll see it later in one of these, I think we'll put in the calculator. You got to understand that. If all you do is blindly put this in the calculator and look and try to copy its graph, it's not going to show this line continuing on very far. When it gets so close to the x-axis that, in terms of the pixels on the screen, it really can't differentiate, it's going to make it look like it touches, but it doesn't touch. So you got to be a little smarter than the calculator on that one. So this is, again, because b is greater than 1, this is exponential growth. The other point to look at, I mean, because of that, it does not have any x-intercepts, but it does have a y-intercept. What's the y-intercept? Where does it cross the y-axis? At 1, right? At x equals 0, y equals 1. Right there. Right there. That is the y-intercept. And if you notice that in this function right here, we didn't have an a. You didn't see an a in front. There was not another number shown. That meant that a equals 1, and that is why this thing equals 1.